In order to understand radians, we need to make sure we have a solid understanding of circumference first. So let's go ahead and review this idea. So the circumference is the measurement all the way around the outside of the circle. So maybe the pizza crust on the outside, or the outside of the bike tire or a car tire, or anything like that, measuring the outside of a circle. And hopefully we remember that the formula for finding the circumference is 2 pi r. And so 2 pi r will give us the measurement of the circumference, where pi, remember, is just a number, so it can be approximated by 3.14. It's actually a decimal that goes on forever. But if we want to just estimate it, then we can estimate it to be about 3.14. And the r stands for the radius. So in the first circle, we have a radius of 3. In the second circle, we have a radius of 4. The radius, remember, is the measurement from the center to the outside of the circle. Now, it could be measured to any point on the circle. So the radius, for example, on the second circle is 4. So from the center to the outside, anywhere on the circle. So from the center to the outside there would be a radius of 4. From the center to the outside, maybe there would be a radius of 4. From the center to anywhere on the circle is always going to be 4. Okay, so if I'm calculating the circumference on this first example, then I have, 2 pi r, pi 3.14, r is 3. And then I'm just going to kind of leave it here for a second and go the 2 times 3.14 is 6.28, just so we can kind of notice some patterns there. And then 6.28 times 3 is 18.4. Same thing on this guy right here. So 2 pi r, 2 times pi, 3.14, times the radius, which is 4. And then again, I'm going to notice the same pattern here. So 2 times 3.14, 6.28. And then I can go ahead and multiply by r, and then I'll get my circumference. Okay, let's go ahead and review one other thing first, and then we're going to come back to this idea and bring it all together. Now, what radians is just another way to measure the angular measure around a circle. So degrees is the angular measure that we are currently familiar with. So for example, going up at a right angle would be 90 degrees, or a quarter of the way around is 90 degrees. Going halfway around is 180 degrees. Going 3/4 of the way around is 270 degrees. Going 360 is all the way around a full circle. And so this is the way that we're currently familiar with discussing angular measure around a circle. And radians is going to be a new way to describe the same thing. Now let's take a closer look at those circumferences that we found earlier. So in our first circle with a radius of 3, I got a circumference of 18.84. And looking at that step right before, it was 3 times 6.28. And maybe let's just think for a second, how about 3 times 6? So 3 times 6 is 18. So it's kind of like 3 times 6 and then a little bit more. So 3 times 6 is 18, and then 18 and a little bit more. Let's see if the same little trick applies here. 4 times 6 would be 24. And then remember, 20 times 6 didn't quite get us there. So times 6 and then a little bit more. So 4 times 6 is 24 and then a little bit more. Is this a little bit more than 24? Yeah, it is. And notice that we multiplied by the same thing in both scenarios. It was the radius, times 6.28. The radius, times 6.28. And so that's why the circumference all the way around is kind of times 6 and then a little bit more. Now, what is that little bit more 0.28 about? Where did that 6.28 come from? 2 times 3.14, or 2 pi. And so we know that all the way around is just going to be the radius times 2 pi. And so essentially our new way of measuring angular measure around the circle is essentially just kind of using the circumference and noticing that the circumference all the way around is just going to be the radius times 2 pi. Now let's take a general circle with a radius of just r. So that r could stand for anything. It could be 3, 4, 10, 12, anything, any radius. And let's go ahead and think about how many radii it would take to go all the way around the circle. And so if I essentially think of taking this radius right here, let's make it red. So if I essentially think about taking this radius and copying it on the outside of the circle, but since a circle is curved, I'm going to have to bend it. So let's maybe call that 1 radius right there. And that looks about the same length. And let's go ahead and do that again over here. Okay, so there's maybe a 2nd radius. And then let's see, here's a 3rd radius and a 4th. And again, I'm really just kind of estimating about how long it is here. Okay, 5 and 6. And if you did it exactly, then you would find out that you're going to be a little bit short of the full circle when you use 6 radii to try and get around. And why are you a little bit short? Well, because it actually takes about 6.28 or 2 pi of them. So we can say that it takes 2 pi radii to get all the way around a circle. So therefore, since 360 degrees is all the way around a circle, then 360 degrees is the same as 2 pi radii, or we're going to say 2 pi radians. And so these are our units of measurement. So degrees and radians. And let's go ahead and think about that in another way as well. So let's compare a couple examples looking at degrees versus radians. So one more time, if I were to go all the way around a circle, and if I'm thinking about degrees, well, that's just kind of what we're used to there. So all the way around is 360. Now, if I'm going to go all the way around a circle, but I want to discuss that angular measure in radians, then I'm going to sort of maybe think, what's the circumference? What would all the way around a circle be when discussing circumference? Well, we talked about 2 pi r. So then, and remember the r stands for radius. So I'm going to think, well, how many radii did it take to get all the way around a circle? Well, I guess it took 2 pi. Okay, and just like we say it's 360 degrees, I would say that's 2 pi radians. 2 pi radians. Okay, so now let's go ahead and think, well, what if I went, say, halfway around? So if I went, say, halfway around, well, halfway around a circle in degrees, that's what we're familiar with. That would be 180 degrees. Okay, let's think about the same thing in radians. So if I were to go halfway around, well, let's see. So all the way around was 2 pi. So if all the way around is 2 pi radians, then halfway around would be half of that. So I guess that would be just pi. Half of 2 pi is just 1 pi. So pi radians is halfway around the circle. And let's do just one more. So if I were to go a quarter of the way around, well, we know that's going to be 90 degrees. And let's think what a quarter of the way around would be in radians. And to think about a quarter of the way around, maybe let's go ahead and think of halfway around. And so just like halfway around in degrees was 180, then a quarter is half of halfway. So if 180 is halfway, then half of that is 90 degrees for a quarter. So if I want a quarter here, well, if halfway around the circle is pi, then a quarter of the way around is half of that, or half of pi. So I really want half of pi here. And half of pi, we could say 1/2 times pi, or just pi over 2. So let's go ahead and do a summary of our 4 important angular measures around a circle in radians. So let's start with the easiest one first. So we know that all the way around, okay, so circumference is 2 pi r. So how many r's, how many radians does it take to get all the way around? Well, 2 pi of them. So 2 pi is all the way around. Well, let's go ahead and move on to halfway around now. So halfway around a circle is half of all the way around. So half of 2 pi is just 1 pi. So halfway around the circle is pi radians. Okay, now moving on to a quarter of the way around. Well, a quarter of the way around is half of halfway around. So halfway around was pi. A quarter of the way around is half of that. So 1/2 times pi, or pi over 2. Okay, our final one here is going to be 3/4 of the way around. 3/4 of the way around. And there's a couple different ways we could think about this. Perhaps you might think, okay, well, a quarter of the way around, that piece of the pi is pi over 2. And so think, how many pi over 2's would we need to go ahead and get 3/4 of the way around? So thinking kind of one quadrant or one piece of this pi here is pi over 2. So I have pi over 2 plus an additional pi over 2 plus an additional pi over 2. So I have pi over 2 plus pi over 2 plus pi over 2. How many pi over 2's is that? Well, that's 3. So I guess that's 3 pi over 2. So that's one way to think about it. Perhaps another way to think about it would be to say, okay, well, all the way around is 2 pi. Halfway around is 1 pi. So I guess 3/4 of the way around would be in between 1 pi and 2 pi. So what's right in the middle of 1 pi and 2 pi? Well, 1/2 pi. So this is really kind of like saying 1.5 pi. Okay, but what is 1.5 as a fraction? Well, 3 over 2. So that's why it's 3 over 2 pi.